Welcome back to Dino's Tinker Shed. This is part 3 of our 4-part series on how to run a project. Specifically, this is about how to sort of restore an old generator unit. Now, in the past 2 episodes, we sort of looked at how to summarize and evaluate your project, and then we dismantled it and broke it into 2 different parts, the frame and the generator power unit itself. And today on the 3rd part, we're going to tackle the engine. We're going to look at the holy trinity of fuel, compression, and ignition, and we're going to adjust the valves and do a few other things to see if we can't get this machine running again. So stick around. This should be fun. Interesting. Well, all right, we got some parts in, which means we can continue to move ahead on the generator project. So overall, I spent around $100 Canadian on parts that I think I'm going to need to get this thing running. And I bought these parts from various suppliers, both from big box stores to sort of specialty stores and a bunch of online companies as well. So I looked at things like fuel lines. We got gaskets for the carburetor. We've got a new air pipe. Got a fuel gauge, which it didn't have originally. And I also got a new spark plug, although looking at the old one, it's really clean. It's burning at the right temperature. And I did have spark with it. The only spark plug I could find that matches this was actually 1 heat range hotter than what it calls for. So I might just leave that one in the box, and in the future I think I'll do a video on how heat ranges of spark plugs can affect performance of engines. I got a battery hold down tray, and as you remember, this machine did not come with a recoil starter, and I promised I would show you a couple options. So the first option was I went to eBay and I found a used cover. It was pretty easy to find. Now it came with the shroud and the rope pulley, came with the rope, the T-handle, and even all the internal components to make it work. -1. It did not have a return spring, and I missed this in the actual description. When I went back, I realized the seller listed all the items that were coming with the recoil, and it did not list that recoil spring. So I paid $15 for this on eBay. Now, instead of buying a recoil spring, I could have done that. If I couldn't find a used one, I ended up just going to Amazon and finding a brand new recoil starter, fully assembled, and it's the right unit. And this was $25. So this really brings up the idea of what's called a false economy. Sometimes you think you're saving money by buying a used part when just a little bit more guarantees the success of your project with a new remanufactured part. Now, this isn't always possible. If you're fixing some older piece of equipment or an older project like the 1980 Spitfire that I worked on, that's a snowmobile, not the aircraft. New parts just aren't really available. There's no one remanufacturing parts either. So you're really out hunting for used stuff. So when you actually look for that, you need to be aware of the condition and ensure that you read those eBay descriptions really accurately so you get exactly what you need. Okay, let's take some of these parts, get them on that generator, and see if we can't get it running. Now I had some help to put the power pack back into the frame off camera. And now I'm going to start reassembling it. And this is similar to if you're putting your frame back in your motorcycle or snowmobile or a golf cart. And what's good is because we had a plan and we took pictures, we know where things like brackets go so that you don't have to come back and revisit. This particular bracket holds the control panel and the carburetor in place. And if you do have torque specs, this is where you start to use them on the reassembly process. Now I don't have that here, but I do tighten them up, you know, torque tight. And I also made the decision to put the control panel back in place here. It just will give us a little bit more room when it comes to diagnosing compression and ignition problems. It's just sort of out of the way here, and it's easy enough to remove if we had to do it again. Now we're going to start our exploration into this engine by pulling out the spark plug. And we're going to do this to take a look at the condition of it. If it's oily or greasy, it could indicate the rings are bad. So let's take a look here. I'm going to have a quick look and I'll show you right here. It looks really good. It's clean. There's no melted electrodes. There's no oil deposits on it. But it is missing the compression washer, which means it probably wasn't building the right compression in the engine. And you can see here, it looks like a brand new plug other than the box end. So what I'm going to do now is I'm going to turn the ignition on and I'm going to rotate the engine with this drill, and I'm going to look for a nice hot blue spark here, and you can see it. This looks great. Now I want to turn my attention to testing the compression. I'm going to do that with this compression tester. Now normally your engine's going to be around 100 to 120 psi, but each engine's different. You're going to have to really research that. Now the way these work is you use these adapters and thread them onto this high pressure hose. Once you get the right adapter that matches your spark plug pitch, you're going to thread that in by hand into the spark plug hole, and you just tighten it in. You know, it's got an O-ring to seal it, and then you throw the gauge on. Mine's a little bit tight. Now again, you're going to need to know what your compression is expected to be before you do this. Now for me, I spin this up with the drill because the electric starter's not working yet, and I'm only sitting at about 65 psi, but then I realize this has a decompression valve in this engine, so this actually is pretty good. And speaking of the electric starter, I don't know if this really works or not, so I'm going to have to pull this out. You're going to have all kinds of different systems on the projects you work on that you're going to have to figure out what you're going to want to test. So for this, it's a couple bolts, and then to get the starter out, you don't want to hit the end of it with a ball peen hammer. I use a piece of hardwood here with a dead blow, and I gently tap the starter out. And eventually I have to just tap the end of the nose of it here just to wiggle it a little bit. Take your time on parts like this. This is almost a $200 starter to buy this. I don't want to damage it if it's actually working. So I disconnect it, I put it up on the bench, and I test it with a battery, and lo and behold, it works. I was thrilled. So I thought you might as well clean it up while it's on the bench. And when you're cleaning stuff like this, there's a series of tools, like I said. I'm going to use this Rotolock head on my die grinder just to clean all the surfaces up. Now this isn't sandpaper, this is what they call a surfacing disc or a preparation disc. And then I'm going to switch over to the bench grinder and just polish it up, just to make all the surfaces clean and make it look nice. It is a project after all. Then I'm going to take a little bit of lithium grease and just lubricate the Bendix here. I don't know if this is necessary or not, but you know what? It's out, so now's the time to do it. And I'm going to fit this back in. I'm confident now that the electric starter works. I'll have to figure out how to wire it up because all the wires were removed off of it, but at least I know that this part of the project works. So let's just tighten it up here, get it put back in place, and we can move on to the next thing. Okay, we know we have good compression, so now let's take a look at the valve train. This is easy. This little cover exposes the two valves. It's an intake and an exhaust. And if you look here, you can see the piston go up and down when I actually rotate the engine, and you'll see the valve train also articulating. Now, in order to check to see if the valve lash or the gap is accurate, we need to test between the top of the valve stem and the rocker arm. Right here, there's a little gap. But to do this, the engine has to be at top dead center. And then we can use one of these feeler gauges here to sort of measure that. These are really inexpensive. You can buy them just about anywhere. So to find top dead center, you want the piston right at the top when both valves are fully closed. So I'm going to insert this large Q-tip here, and I'm going to rotate the engine and take a look at the intake valve. So the intake valve comes up, the exhaust valve goes down. Then when the exhaust valve comes up, I'm going to watch the head of the piston, see how it's coming up with the Q-tip. When it just starts to go down, we know we're at top dead center. Now I'm going to use that feeler gauge, and the exhaust valve is 0.2 millimeters distance between the valve stem and the rocker, and it's a little bit loose here. The intake valve is pretty good, but we're going to adjust both of these. So to do this, what we do is we hold that one large nut, and the small jam nut on the top we're going to loosen. Now the large nut that's being held with the spanner wrench can now be turned by hand to adjust the gap between the top of the valve stem and the rocker arm. And you'll see how it's a fussy job. It takes a bit of practice. You want a nice fit where it's snug. You don't want it to just sort of float in there. And you just keep adjusting that large nut until you get it perfect, and gently turn the jam nut in. This is where you can actually bump the big nut and adjust it accidentally. I'm going to tighten the jam nut up, and then I'm going to check again to make sure that I have the right gap between the valve and the rocker arm. This is looking good. Great, I like it. So you'll notice I took the time to polish the valve cover. Now this has a large gasket on it. This doesn't need to be tightened down very hard. I just use a nut wrench here. Okay, so we've determined that we have good compression and we have good ignition on this engine. So the third and final component of the Trinity is fuel supply. And with these small engines, what I've really found over the years is the carburetor tends to be the biggest problem when you have an engine that won't start or won't run smoothly. They're usually gummed up from years of sitting in a garage with old fuel in the system. So we checked the first two parts of the system because they're really easy. Spark and compression, it's easy. Now we're pretty confident that we're going to be able to clean this carb out and make the fuel system run well. Now I'm not going to go over how to clean this particular carb in any detail, more generalities about draining out the old fuel like you see here, and just breaking it down into all of its components. So you take all the float bowls off, you're going to want to pull the floats, the jets, so there's usually a main jet, there's a pilot jet, there's an emulsion tube, there's an air mixture or fuel mixture screw in every one of these small carbs. And really your job here is to pull it down as far as you can and clean each one of these components as the best that you can. Now for me, I've got a few different options at my disposal. Things like toothbrushes and small bristle brushes work really well to get large parts of the gunge out of these, for lack of a better term. But as you get further into the system, you can use things like either a carburetor or brake cleaner to give you a hand to clean these things out. It's important, of course, as you take these apart to keep track of all the little parts. There are little needle valves and floats and springs in some of these carbs that you want to have a system to be able to reassemble it. And you can really see here just how dirty the inside of this carb was. It really was in desperate need of cleaning, and probably this wouldn't have run if I put fuel in it. In fact, the needle valve itself was stuck. So here I'm using a specific carburetor cleaner, and this cuts all the varnish. I'm going to pull all the tubes off, and then for me, I can throw it into my ultrasonic cleaner for a half hour or so, and you can see, look at how clean the float bowl is now. Now ultrasonic cleaners, I got a great video on this particular ultrasonic cleaner, but look at how nice it's cleaned the internals. And now it's just a matter of reassembly. Going back and taking all the components that you took off and reassembling them into the carburetor so that they function. And you want to make sure that as you put these things in, you check them. So the float, you want to make sure the float height's right and that it functions well, the needle goes in, and you get all the gaskets back in place, like this one on the float bowl. This is really what it's about. And these torch cleaning tips, or torch tip cleaners, are available at any welding shop or even your home center. And they can be used to clean all the little holes like on this emulsion tube where you just slide them through. Now you don't want to file these holes any bigger than they are, but these torch cleaning, torch tip cleaning, wow, I can't say that. They really do make a big difference. And then again, it's just about reassembly, making sure not to damage anything when you put it back in. And here you can see, it looks like the air mixture screw that goes in. Now these have these little pinhole things on them that were hard to adjust. I just did it with my fingers here. I backed this out 2.5 turns. That's usually where they sit. But you can see here, this is the float, what holds the float bowl in, and the washer that was on there was so bad that I had to make a new one. And this is what's kind of fun. I just buy some gasket material and make my own washer, basically sealing washer. So I'm going to use these verniers just to measure the outside diameter of that shaft, and I don't really measure it, I just lock it in, and then I use the opposite side of the verniers to measure the hole on these hole punches. This one seems to be the right size, so I'll put a piece of hardwood underneath there and I'll just give it a whack. Boof, there we go. And see, it makes a nice clean hole. These are pretty cheap. You can get these for about 14 bucks for a whole set, but it's a little too big. Sometimes that happens. So I'll drop a size here and I'll make a new hole. Now, I could go and try to find this gasket, but honestly, having some gasket material in your shop means you can do this and not have to run out for new parts. Yeah, it looks pretty good. So what I'll do is I'll just use a larger hole punch here, and here comes our washer. Bang. Now what you're going to notice is I don't quite have this centered. Yeah, it's not a big deal. It still is going to provide us with the right amount of sealing. So I'll just slide it on here, and you'll kind of see that it's not perfect, but it's not bad either. And again, you need to know what battles to fight and which ones not to. So I'm not going to die on that hill. Okay, so I'm going to put this back together. I'll thread in that new gasket that we made. And you know, when dealing with small stuff like this, don't over tighten these kinds of things. They just need to be snug. Everything has a gasket or an O-ring. And here you can see just putting it all back together. The carburetor, you can spend probably the most time cleaning this, getting it put back together. And I encourage you to take your time when doing this. You can put these things back together in the wrong way sometimes, and it just won't run right for you. But for here, we got her good. So this little guy on the bottom here is your fuel shutoff for the electronic control panel. Basically, when you turn it off, it shuts it off. Now, again, I'm going to use one of these surfacing discs. It's not sandpaper, and I'm just going to clean the surface up, and we're ready to go. Now, before I put all the cover plates back on, I want you to have a look here at this magneto, or this coil pickup here that rides against your flywheel. Now, this is what actually produces the spark that we tested earlier. Now, it's functioning, but it's pretty rusty and gross, and I just want to make sure that it is gapped right. It's a quick step for you to do. So we're going to pull the coil pack off of here, and we're going to take that magneto and we're going to clean it up on the bench grinder. Now, make sure there's loose wires here. See how I hold it so that it doesn't get caught in the grind, or in the wire wheel here. And I'm just going to gently go through and take the light surface rust off. Now, this actually, this magneto picks up the permanent magnets on the flywheel, and I think it's through the Hale effect, generates power. But it has to be gapped similar to the valves. So once I get it in, I'm going to reroute the wiring for it over to the control panel, and I'm going to plug it in down here. See how I've labeled all the wires when I took them off? Oh, here it is, the coil wire. And I'm going to coat this with a little bit of dielectric grease, which is going to stop it from corroding, and it's going to keep moisture out. This is cheap. It's like $7 for a whole tube. It'll last you your life just about. And I'm just going to plug that in so I know the coil's ready to go. And then we're going to turn our attention to gapping it, and we're going to do that with the same feeler gauges that we used for the valves. So I'm just going to lightly snug this down. You can see the holes on the magneto or the coil pack actually are oblong, so that you can move the coil in and out from the flywheel. And I'm going to gap it as per spec on both the top and bottom, and then tighten it down. And this will ensure that we have the exact right gap to generate our spark. Now, anytime you're doing a project like this, vacuum lines and fuel lines are a must to change. Look at how cracked this one is. And be careful when pulling these things off, especially on plastic fittings like this. You don't want to damage anything, so give them a little twist when you bring them off. Now, changing vacuum and carburetor lines will ensure you won't have any problems when you go to fire the machine up. So we can get to some reassembly, and I'm going to use a new set of gaskets for the carburetor here, just because they're a bit of a precision item. And when you get to put stuff like this back together, make sure you put all the linkages in the right places and you test them as you go along. So you'll see here I put on the choke bracket and I'm just going to temporarily fasten it in place to make sure the linkage functions right. I actually put it on backwards the first time. Now we're going to turn our attention to some of the airbox, just cleaning it. And this could be any component that has to be put on there, any kind of plastic component. Sometimes you can get gaskets off, I can't there. So I'm just going to go along and clean this whole thing with some brake cleaner and getting in all the nooks and crannies using a screwdriver. I fasten all of the wiring back into the normal places, and remember I labeled all that so that I could get it plugged into the right connectors on the wiring harness. And then I fit up the plastic parts. And take your time here. Sometimes these can be a little bit challenging. I have a feeling the frame's a bit bent because the airbox is hard to get on here. So again, I'm going to fasten this in and I use very light touch. Now what I found is one of the nutserts that was inside the airbox was stripped out. So I actually have what's called a Nutsert tool. It's like a rivet gun, only it allows you to place these threaded inserts into plastic or wood or steel. So the way these work is they have a series of different thread pitched ends. You match up the bolt that you have to the right thread pitch on the I guess it would be the expander bolt, I suppose. I don't know what you'd really call it. So you can see here it fits the nutsert properly. And then this gets threaded left-handed into the gun itself. And then this left-handed threaded collar fits in behind it. Now this is a really cool tool. I use this quite a bit for making racks and things. Next you thread the new nutsert onto the end. And you match that diameter with a drill. So I'm going to drill the plastic out here with a drill. You insert it like a rivet gun, and then you squeeze it. And it actually flares out the nutsert. And you just unthread the tool from it, and all of a sudden you have threads in plastic. It's amazing. Look at that. It works great. Cheap tool, about 40 bucks. And that allows us to finish putting the airbox together. Now look at this. I'm going to use a little bit of starting fluid here. Bang, fires right up. We know we're on the right track. Look at that. It's great. All right, we don't want to damage that nice clean carburetor, so I'm going to pull off the petcock here. And you can see I put a little mark there which way the actual output was facing. And this has a gasket on the bottom that we're going to replace. So again, it's all about cleanliness. I'm going to come in here and clean it. I'm going to blow out the petcock to make sure there's no crap in there. And then I'm going to run it over to the wire wheel and clean it up so it looks like brand new. You don't always have to buy new things. Now I'm going to take a look inside the tank, and I know it's not the cleanest in here. I'm going to pull this pre-filter out. It had a little bit of debris I knocked out, and I'm going to clean that with a little bit of brake cleaner. But I'm going to stick an air hose in here and look at the amount of dirt. It's just dirt that's coming out, and I keep blowing this out for quite a while, and then I run a long flexible magnet in to make sure there's no steel or anything, any kind of rust particles that are coming off, and I'm pleasantly surprised. It's really just dirt in there. So I finished cleaning that out with some air, and I rinsed it with a bit of gas, and now I can put in the new fuel gauge. So this had a rubber plug in it. Originally I put a new fuel gauge in. When I put the petcock back in, I'm going to put a new O-ring, and I'm going to put some Teflon tape on the threads. And I just thread this down, line it up to the mark I made, and then tighten this lock nut down to seal it. And this is an area where gas can leak. We're going to check that when we finally put fuel in the system. Now it's just a matter of putting the tank back in place and putting some new fuel lines on. Now originally I was going to put an inline filter, but I didn't have one that was small enough to fit the fuel line. So I just directly routed it, and it's a little bit challenging here even to get this fuel line that I had onto the petcock. It took a couple tries, but eventually I got it on there and put on some fresh clips. So we're getting really close here. I'm just gonna mount this down with some bolts, and we're getting close to actually trying out this unit. I'm excited here. We're gonna actually get to fire this up. So I'm going to add some fuel, not a lot, maybe half a gallon in here. just enough to fill the bottom of the tank and look for leaks. And the first place I'm going to look for leaks is at the petcock. Now I've got the petcock closed here, and I feel around there with my finger to make sure it's not leaking at the spout, and it's not. So I open up the petcock and you can see the fuel running through the clear lines here. So now it's filling up the float bowl on the carburetor, so I'm going to feel the bottom of the carburetor and we're good. So now it's the moment of truth. One choke, here we go. Oh, I love it. Can you believe how well that engine started? I was blown away. It truly, honestly did start on the very first pull. And I really do attribute that to a few different things. Number one is I really think I underestimated the quality of these Chinese Honda clone engines. I mean, the thing runs perfect. We adjusted the valves, everything works really well, and it runs smooth, smooth, smooth. Secondly is we had a roadmap of what we wanted to do to this engine and this project overall. But importantly to the engine, we wanted to check the Trinity, the fuel system, compression, and the ignition system, and we did that. We cleaned the parts that we had to, and in the end, when we pulled on the cord, it started right up. And this is the point of this particular series. It's not about this generator that's on the floor here. It's about your project and keeping your project on the move. And we do that by good organization. Sometimes you need to slow down a bit to speed up. Take a step back, see what your problem is, and call for help when you need it. And that's what's going to be a part of our next part of the series, is the Jenny part of the unit. I don't have a lot of experience with that, and I'm going to be honest, there's no power coming out of it yet. So I phoned a friend who's an electrician, and he's going to come by next week and see if he can give me a hand to determine whether or not that Jenny unit is really worth salvaging. And if it's not, well, we'll figure out what we're going to do with it after that. So please keep your comments coming. I wanted to mention that. They are really, really fun to read, and they really have helped me to sort of pick the directions in which I'm going with this channel in moving forward as well. So until next time, I'm Dino. You have yourself a great day, and I'll see you soon on Dino's Tinker Shed.